There are elements that are typically found in nature as just a collection of molecules under ordinary conditions. And these elements are the halogens. Okay, if you find halogens in nature, in pure form, typically you'll find them as a collection of diatomic molecules. So fluorine, the formulas F2Cl2Br2 and I2, those are the formulas for the molecules that you'll find. So typically when we're referring to fluorine, the substance, we write F2. We're referring to fluorine, the element, the atom, we just write F. But if we're actually referring to the substance as we find it in nature, we say the formula for that substance is F2. We're talking about fluorine. Chlorine, Cl2, bromine is Br2, iodine is I2. Oxygen is also typically found in nature as a diatomic molecule, O2. Nitrogen is also diatomic, N2. So oxygen and nitrogen are the main components of air. Okay, nitrogen is about 70%. Air is about 80% nitrogen, approximately, and about 20% oxygen. Okay, so there's a few other molecules in air, but the primary components of air are nitrogen and oxygen, and they are diatomic. Okay, so if you're referring to the oxygen in the air, that's O2. Okay, hydrogen is also diatomic under ordinary conditions. Phosphorus, you may find it as a collection of polyatomic molecules with a formula of P4. Imagine a pyramid. Okay, and you have in your pyramid, you have phosphorus at each corner of the pyramid, four corners of the pyramid. And sulfur can be found as a polyatomic molecule. Okay, it's a molecule S8, so that the way they're linked up is, imagine a stop sign with which is an octagon, right? So you can, it's a good thing to remember, a good way to remember it. Sulfur S8 looks like a stop sign. It's an 8-membered ring. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that's 8 sulfur atoms in forming a ring. And phosphorus, good way to remember, P is for pyramid. So P4 looks like a pyramid. Okay. Graph diamond can be considered as just one giant molecule consisting of covalently bonded carbon atoms. So diamond is a form of carbon, same as just like graphite. The lead in your pencil is actually not lead, it's actually carbon. Okay, so what's the difference between diamond and graphite? They're both made of carbon. You can actually think of these as just giant molecules, giant in the atomic sense. Okay, that means there's lots and lots of atoms. Let's do a Google search for diamond images, structure. So this is how the atoms in diamond are connected, right here, something like that. Okay. So each diamond you can think of is in the center of a pyramid. So it's surrounded by 4 other atoms. A pyramid, by the way, is what's a pyramid? It's like we have 4 triangles, right? One triangle there, a triangle there, a triangle at the bottom, a triangle at the back. So you have 4 triangles. Okay, so it's a 4-sided figure. So you say it's a tetrahedron. Tetra in Greek means 4, hedron means sides. So a pyramid is a tetrahedron. So you say the arrangement of the atoms in diamond is tetrahedral. Okay, so you can say, imagine each of these, this atom right here, for example, is in the center of this pyramid right there. So each atom is connected to 4 other atoms. And so you imagine each atom as being the center of a pyramid. And then this edge of the pyramid will be centered. So this is just a small part of it. Let's look for a bigger picture right here. Okay. So each one of these atoms would be the center of a pyramid. Okay, and it just stretches out. Now, what about graphite? Graphite, okay, let's look at pictures of graphite. How are the carbon atoms organized in graphite. Here's a good picture right here. There's several pictures here. You'll notice it's a collection of flat sheets. You can say each of these flat sheets. Okay, so here's one flat sheet, another flat sheet, another flat sheet, another. So each one of those sheets would consist of carbon atoms that are arranged in like honeycomb-like pattern. It's hexagons. Okay, so you have carbon, carbon. Each carbon would be in a pattern that looks like this. See, carbon, carbon. So you have fused hexagons. Okay, so you have a sheet of that fused hexagons is called a graphene molecule. Okay, so you got this long, it's really large, not long, but long and wide sheets of graphene stacked one on top of each other. Okay, so this is one graphene sheet, there's another graphene sheet, and there's interactions between these graphene sheets that holds them together. Okay, and the way your pencil works is when you rub your pencil against paper, you're taking out a layer of graphene and putting it on your paper. Okay, and so that's what graphene is. Now the molecules, you've heard about the ozone layer. This is this layer in our atmosphere that protects us from harmful rays from the sun. Okay, a form of oxygen you'll find there is O3. Okay, you find O3 molecules there. Those are ozone molecules.